see.
Got it?
Okay.
Go to page 1.
All right, let me see. We've got, all right, I see Grayson's tree map. I see Weston.
Go to page
I can't see. Sean. I see your tree map. Okay, who else over here? Let's see tree map. Miss Newbers. Okay, I see Paisley and Gavin and Lily and Layla and Lillian. Is that Lillian? Yeah. Gage. What's his name? Daria, Bennett, Gianna. You guys getting yours? Henley, Avery, Layla. Where's your tree map like mine? Is that good? Yeah. I mean, okay, do you have your tree map out? Do you have your book?
And make sure you've
Ready?
got your
Open your
tree map in your reading book. If you have a second grade reading book. If you
Okay,
do
I
not
see.
have a second grade reading book, remember
job.
it's online. Okay, Jalen, you need to go ahead and mute your microphone. Thank
Is
you,
that
buddy.
the Martha Harris that I just gave you?
All right, guys.
We're not doing any writing right now, we're just watching. I just wanted to see your tree map.
We're going to open our books to page 129. Page 129. Who remembers what stage, what is matter? Does anyone remember what matter is? Destiny, do you remember what matter is?
Okay, just put it right underneath.
Yes, solid, liquids, and gases. But matter has to have two things. What does matter have to have? Look in your books, page 124. What does the book tell us that matter has to have? Two things.
Dominic,
Dario, are you
come
looking?
down the carpet. Come on, get that book.
Okay, the book, what does it tell us it has to have?
Mass and volume.
Mass and volume. Okay. Okay, make sure you're muted. Okay? All right. So mass is the amount of material in an object, and the volume is the amount of space an object takes up. We talked about not gases, I'm sorry. We talked about solids yesterday with Miss Turnage. Who can tell us something about solids? Harper, what can you tell us about solids? They don't what? They do not flow. Okay? They do not flow. A solid does not flow. Good job, Harper. Somebody online, what can you tell us about solids? Gage, can you tell us something about solids? Gage?
Jessica.
Can you tell us something about solids? Who can tell us about solids? Ianthe? Ianthe, what can you tell us about solids? Unmute.
Can't see the board.
Yeah, a solid cannot be easily compressed or squished. We talked about that yesterday. Okay? They're not going to change their shape very easily. Okay? A solid. Do you remember anything else about a solid? Evie? It does not change its shape. Okay? All right. Grayson, one pencil. Okay, today, boys and girls, we're going to talk about two other types of matter. The first type of matter we're going to talk about are liquids. Okay, look at page 129. If you have a second grade book. If you do not, it's okay. There's books online. Okay, your book is online in Google Classroom. Okay. Okay, liquids on page 129. Oil, syrup, and water are all types of liquids. Liquid matter does not hold its own shape. Okay, what did I just say? That's important. What did I just say, Callie?
What page?
That's right, it does not hold its own shape. Remember Miss Turnage had some water in a bottle yesterday? And when she poured it into the cup, what shape did it take? Did it still look like the water bottle? No, it looked like the cup, right? It took the shape of a cup.
Stay there.
Liquids take the shape of their container. Whatever container they're in, they take the shape of their container. Water inside a swimming pool takes the shape of a pool. Okay? If you look at the pictures, oil is an example of a liquid, and water in the pool is also an example of a liquid. Okay? So if you think of cooking oil or water in a swimming pool, okay, who wants to tell Miss Turnage something to put on her map? I know we talked about a couple things about liquids that's important.
So what goes up in the top line, right here? Let's get Harris's group. Jessica, what goes on my top line? We have solids here. What do you think is going to go here?
Liquid.
Liquids. We have to put what we're talking about at the very top.
Liquid.
So this is where you should be starting to write yesterday, and you always start on the left, just like you read. Left to right, left to right, left to right. So now we're in the middle. So we're going to be talking about liquids today. And already, what did you say about liquids?
What did we learn about liquids already on page 129, Abby?
Liquid matter does not hold its own shape.
Yep. So yesterday we said a solid does hold its own shape. But today, girls, pay attention, we're saying that it, if you need to move, Brea, where you can see, go ahead. It does not, and I'm going to underline not, hold its own shape. See how I'm staying under liquids, right? Because that's a tree map. So solids hold its own, liquids do not. Do you want to see an experiment?
Yes. Yeah.
It's not that big of a deal, but I do have some liquids we decided upon to use. So we said liquids do not hold its shape. Okay, so here's this in a water bottle, right? What kind of shape is that? Anybody know what kind of shape this is around?
Is it a cylinder?
Yeah, whoop whoop, it's a cylinder. So, if I pour this water into this cup, I want you to put your hands on your head if you think it's going to take the form of the bottom of this cup. If you think it will change shape to the bottom of this cup, put your hands on your head. All right, I'm pretty sure you're right, because we know it's going to take the shape of whatever it's in. So what if I pour it into the lid of this cap? What's it going to do?
Change the shape of that cap.
It's going to change to the shape of this cap. Now you can do all sorts of experiments today in the bathtub or the sink or outside. You get all sorts of containers and just switch it up, right? Okay, so what if I had a different kind of liquid like soap? Soap's kind of thick, isn't it? And hand gel? Well, if I pour this soap into this container, is it going to change shape?
Yes.
Absolutely. If Italian dressing, is Italian dressing a liquid?
Yes.
If you agree that Italian dressing will flow and that it will change its shape when I pour it, put your finger on your nose. What do you think, Jaden? Is this Italian dressing going to change shape? What do you think, Jayla? What do you think, Ryan? What do you think? Just slow it down. Okay, I see some good answers right here. It is definitely going to change its shape. It's going to flow onto my salad. Right? Watch this. Watch it flow. Oh, it's flowing. And I need extra dressing, please. Okay, so I'm flowing, my stuff's a-flowing. And we're going to talk more about different types of liquid later.
All right, turn to page 130 in your book. Just turn the page.
Sorry.
Okay? liquids are not easy to compress. That's very similar to what? It said it's not easy to compress. Very similar to a solid. Okay, it's not easy to compress. Milk is a liquid. You couldn't fit the milk into the jug in a little carton. So if you look at a gallon of milk, okay, and you tried to put that whole gallon of milk into this little milk carton, okay, it wouldn't work, right? What would happen to the extra milk once the container was full? What would happen?
It would overflow.
It would overflow and spill out. So you cannot compress a liquid, okay? You couldn't fit the milk into the jug from the big gallon of milk into the little carton, okay? Another thing about liquids is that they flow. Liquids flow. Think of syrup when you spread syrup across pancakes, okay? What happens to the syrup as you're putting it on your pancakes? What does it do? It flows, doesn't it? It flows right across your pancakes. So do you think that's something important that Miss Turner should put on the tree map?
Yeah. I'm not sure what to put for compress.
It says they're not easy to compress.
So liquids are not easy to compress because of why?
Why? Why do you think we can't compress the liquid?
Who said that? Ryan. Jessica, you know the covers. It takes up more space sometimes, or less space. Okay.
Why does it overflow? Can't we press it down and squish it in that little milk container? No. No, you cannot squish a liquid. It's not going to compress. Okay?
I'm going to go around.
Okay. It's not going to compress. Okay. Tell me, what have you learned? How are solids and liquids alike? What is something that is the same about solids and liquids?
They are both not easy to compress.
Yeah, they're not easy to compress. Okay, you cannot compress them. What was something that was different about solids and liquids? Something that was different about solids and liquids.
The solids are hard and the liquids are
Okay, Lena said the solids are hard. Does anyone want to help her? Do you want to add a little bit more to that?
and the liquids can flow.
The liquid flows. Okay, does the solid flow? Think of the water experiment. Okay, the liquid flows, but the solid does not flow. Okay, now we're going to talk about one more state of matter today. Are you ready for this one? Who knows what the last state of matter is? Let's see, somebody online, let me see. Who's paying attention? Jalen Roundtree, what is the last form of matter? We've got solids, liquids, and what's the third form?
Everybody, 1, 2, 3, unmute.
Gases.
And I'm not going to write this one down, so you're going to have to pay really close attention.
Yep.
Because you have to find the reasons in your book about gases, and you're going to do that for Wednesday's homework. Tonight's going to be liquid, or today, and tomorrow when you're not here, you're going to write about gases. And when you come back on Thursday, or by Thursday, you're going to submit your whole tree map for a big grade. It's a science grade and a reading grade, so it's worth 2 grades. So if you haven't started your tree map, you need to do it.
Okay. All right. So air, steam, and your breath are all gases. Take your hand, and I want you to hold it in front of your mouth, and I want you to blow air out. Do you feel that? Oh,
I'm helping you.
I know. What's inside those bubbles Miss Turnage is blowing? Air. Okay. It is a gas. Air is a gas. Okay. Your breath is an example of a gas. Okay, it's another example of a gas. Gas matter does not hold its shape. Okay, it does not hold its shape. Gases take the shape of whatever container they're in. So those bubbles that Miss Turnage was blowing into, what shape did the air take? A circle or sphere shape, right? Okay, it changes. The air inside a hot air balloon takes the shape of a balloon. And if you're looking on page 131, you should see a hot air balloon. When there's air going in that hot air balloon, it takes the shape of the hot air balloon. Okay? Yes, sir.
I have an example of a gas.
Okay.
Like the smoke from a volcano when it's about to erupt.
Good.
It comes out.
Very good. Let's look on page 132. I think there's one more experiment Miss Turnage might do. Gases are very easy to compress. Carbon dioxide is a gas, okay? It's inside of, guess what? Carbon dioxide is inside, what is this? This is Miss Stuber's, what is it? A soda can, okay? It's a soda can, okay? What happens when you squeeze the soda can or you open it?
Air flows out.
It explodes. What happens? What do you think is coming out of that can when you open it?
Put your pencil down, Grayson.
Air, gas. There's gas in there. And
Grace.
gas is easy to compress and shove down into that little can. Okay? It's squeezed inside the cans. And that's what actually gives soda the bubbles. Okay? That gives soda the bubbles. Carbon dioxide rushes out of soda cans when you open them. Listen.
Ready, Grayson? I want you to watch this experiment, then you can write again. Okay? Well, you know what it sounds like. How does it sound when it comes out? Go. It's the sound of an X. Go. Do it really hard. All right, here I go. See if you can hear it. Listen with your ears. Ready?
Did you hear it?
Yeah.
Yeah.
And what if I pour it? What's it become? What's it in? What is a can?
A cylinder.
A cylinder.
Now, what kind of solid, liquid, or gas?
The can is a
Solid. What's inside of the can?
liquid. And gas.
Gas.
Dioxide.
Carbon dioxide? I'm not sure. You might be smarter than me. So if we pour it, can we pour it in here?
Yeah.
If we pour it, what is it?
A liquid.
Is it flowing?
Yes.
Is it taking the shape of this
Yes.
solid? Could it overflow?
Yes.
Yes.
It could.
Is it? Oh, it's got bubbles. What are the bubbles in there?
Air.
What is air?
Yes.
Gases. Man, this pop has all three of it in there. This is a great example.
Carbon dioxide.
Okay, so I'm gonna keep pouring because I'm thirsty. See that flow?
Yeah.
Okay.
It
And
flows.
then it's taking the shape of this cup. All right.
All right, so gases flow. Think of the bubbles that Miss Turnage just blew. Okay? The air inside a bubble spreads to fill the space inside the bubble. Okay? Why do you think that the air inside the bubble spreads? Why do you think it spreads? What is air? It's a what? It's a gas. Okay? And the particles inside of gas they spread out.
What's that?
When the bubble gets too large, what happens? When it spreads out too much, what happens to the bubble? It pops, right? It pops. When it's too large, it pops. Okay, so we talked about liquids, we talked about solids, liquids, now we have gases. What were some of the characteristics of a gas that we talked about? What were a couple things we said about gas? We know that solids hold its own shape. Liquids do not hold their own shape. What about a gas? Does a gas hold its own shape? No, a gas does not hold its shape. So it's more like a what? A solid or a liquid in that capacity? It's kind of like a liquid. It doesn't hold its own shape. Okay? And gases are very easy to, what did we do to the gas in the soda can? We compress them. Okay? They are easy to compress. Whereas the solid and the liquid are not easy to compress. Okay? And we know just like liquids, gases what?
Air.
It starts here and then it flows. It flows. Think of air freshener. Think of an air freshener or perfume. You spray it, right? If I do one spray, it starts out right here. But what happens to the air freshener? The scent, it spreads like this. So it flows, okay? What other form of matter flows? Solids or liquids? Liquids. So gas in some ways is very similar to a what? It's similar in a couple of ways. Very good. All right. So tomorrow, my friends, you are going to read what you're going to reread what we just read today about liquids and gases, okay? And then Ms. Turnage said that you are going to fill in the third section the second and third parts of your tree map.
This is today, and there'll be a picture just like there was last night. You don't have to think of this out of your brain. The solid and the liquid is on the Google Meet video. It's on it. Just copy it.
There's a picture.
There's a picture of it. So but the gases, the very last one is you're going to do by yourself on Wednesday, and all of it'll be done by Thursday. You have to submit it by Thursday. Picture of it.
Okay, so your tree map is due Thursday. Okay, you need to have a solid section, a liquid section, and you're going to fill in the gas section as well. Okay, tomorrow for reading and science, we're integrating it this week. There's going to be a Brain Pop Junior video and a little drag and drop activity for you to sort the different types of solids and liquids, okay? Give me a thumbs up if you're good with that. It's a fun little activity. Fun little activity. I even put a picture of my little baby in there. Ooh. My little baby's in there. See if you can figure out who my little baby is when you do your activity tomorrow. Okay? All right. So Miss